Imagine an AI model so efficient it can do almost everything its massive predecessor could, but at a fraction of the cost and size. That's Meta's Llama 3.3, a multilingual powerhouse with just 70 billion parameters compared to the jaw-dropping 405 billion of its predecessor. What's impressive is that, despite the significant environmental effort, it still delivers nearly the same performance. But what does that mean for you? Well, it means lower costs, less strain on GPUs, and a huge leap in making AI tools and VR worlds more accessible. So how did Meta pull this off? And why does this model have the potential to reshape the future of AI and VR? Let's dive in to find out. Meta's Llama 3.3 is making waves in the world of AI, and here's why. With 70 billion parameters, this multilingual large language model is as lean as it is powerful. But don't let the smaller number fool you. This model is going to be a game changer. Meta's previous Llama 3.1 had a staggering 405 billion parameters. Llama 3.3 slashes that by over 80%, yet still manages to perform almost on par with its predecessor. That's efficiency on a whole new level. It's like owning a sleek sports car that's just as fast as the top-tier model, but is cheaper to run, takes up less space, and is easier to maintain. Meta has positioned Llama 3.3 as an open-source powerhouse, and the numbers are mind-bending. It has over 650 million downloads so far, an adoption rate most companies could only dream of. Why? Because developers worldwide are building on Meta's foundation. Here's the brilliance of open source. The more people rely on Meta's tools, the deeper its influence grows in the AI ecosystem. Imagine a world where most AI apps, tools, and systems are rooted in Meta's infrastructure. That's not just market presence, that's market dominance. But how does this play into their bigger vision? That's where VR and the metaverse come in. Imagine a future where the lines between AI and VR blur, creating immersive experiences powered by some of the most advanced technology on the planet. Meta's strategy is clear: control the leading AI tools and the leading VR tools. If they succeed, they'll be writing the rules. The metaverse, once a buzzword, is starting to look like a calculated blueprint. To make this vision a reality, Meta is teaming up with third parties to expand their VR ecosystem. The goal? Make their VR tools the industry standard, just like Llama 3.3 is becoming a cornerstone for AI development. Think about the possibilities: AI-driven virtual assistants, hyper-realistic virtual worlds, and seamless digital interactions, all powered by Meta's integrated AI and VR infrastructure. To make their AI and VR vision a reality, Meta is going all in on infrastructure. For starters, they've announced a brand new AI data center in Louisiana, designed to supercharge their AI operations. But that's not all. Meta is also investing in an undersea cabling project to handle the massive data loads their AI and VR ecosystems will demand. Whether it's AI tools or immersive VR worlds, anyone who wants to play in this space might end up relying on Meta's ecosystem. But it's not just about the tech. With 600 million monthly active users already engaging with their AI features, and a total user base of over 3 billion across Facebook, Instagram, WhatsApp, and Messenger, Meta is perfectly positioned to integrate these advancements into everyday life. Llama 3.3 isn't just another AI model, it's a marvel of efficiency and power, packing groundbreaking advancements under the hood. For starters, it's trained on a staggering 15 trillion tokens. To put that into perspective, its predecessor, Llama 2, used only 2 trillion tokens. This massive leap in training data translates into significant gains in reasoning, coding, problem-solving, and even multilingual understanding. Llama 3.3 can handle context windows of up to 128,000 tokens. That's the equivalent of processing an entire book's worth of information in one go. Imagine the applications, from analyzing extensive legal documents to powering advanced research tools. Meta has also implemented grouped query attention to enhance memory efficiency and speed during inference. In plain terms, this means the model generates responses faster and at a lower cost. Developers can now generate text for as little as 1 cent per million tokens, a fraction of the cost of rivals like GPT-4 or Claude 3.5. And the hardware savings? They are phenomenal. The older 405 billion parameter model demanded nearly 2 terabytes of GPU memory for inference. On the other hand, Llama 3.3's efficient design requires only tens of gigabytes, saving developers potentially hundreds of thousands of dollars in GPU costs and energy consumption. With great power comes great responsibility, and Meta seems to recognize that. Llama 3.3 is open source, but it's not a free-for-all. Developers must follow Meta's acceptable use policy, which prohibits harmful applications like generating malicious content or enabling cyber attacks. For larger organizations, those with over 700 million monthly active users, a commercial license is mandatory. And every application built using Llama 3.3 must credit Meta, ensuring transparency about its origins. Meta has also implemented robust safeguards like extensive red teaming exercises, where security experts stress test the model for vulnerabilities. Features like Llama Guard and Prompt Guard act as digital sentinels, minimizing risks of misuse. Training Llama 3.3 required a significant 39.3 million GPU hours on H180GB hardware, which generated about 11,390 tons of CO2 equivalent emissions. However, Meta ensured the use of renewable energy to achieve net zero emissions during the training phase. The model demonstrates consistently high accuracy across a variety of key benchmarks, which are essential for evaluating its performance across different domains. In the MMU, Massive Multitasking Understanding benchmark, it achieves an impressive 86% accuracy, showcasing its proficiency in handling diverse tasks and scenarios. In mathematical problem solving, it performs at a solid 77%, demonstrating its ability to tackle complex calculations and reasoning tasks. When it comes to coding tasks, the model excels with an accuracy of 88.4%, reflecting its strong coding capabilities and understanding of programming languages. Furthermore, the model is highly effective in multilingual tasks with an outstanding accuracy rate of 91.1%. The model is highly accessible to developers and researchers, with its availability on well-known platforms such as Hugging Face and GitHub. These platforms enable easy access to the model, allowing users to experiment, fine-tune, and integrate it into their own applications or projects. Additionally, the model supports fine-tuning through Meta's TorchTune library. The model is also compatible with major cloud services, including AWS, GCP, and Azure. This ensures that users can easily deploy the model in cloud environments for scalable and efficient computing. Meta envisions a future where AI, VR, and wearable technologies converge to create immersive, seamless experiences. AI will enhance virtual environments by adapting to user behavior, while wearables will offer personalized, interactive interfaces, bridging the physical and digital worlds. Meta's commitment to this integration is poised to redefine daily technological interactions. Ultimately, Llama 3.3 offers developers powerful tools to build intelligent applications, benefits businesses through automation and decision-making, and enhances user experiences with more efficient, AI-powered solutions. If you found this exploration helpful, don't forget to like, comment, and subscribe to stay updated with the latest insights. See you in the next video.